Hey everyone, welcome to my stream. Just gonna post that I'm live, just give me a second. So, I have been busy since the last stream. Ah, here it is. Okay. So yeah, been pretty busy. Just mainly working on refactoring a bunch of code. Yeah, just a bunch of stuff. Let me see here, just to get an idea. So I streamed on the 11th, which was here, and then after that, I worked on the 12th and on the 13th a bunch and made a bunch of commits. So I won't go over into these. I won't go over these into too much detail because they're mainly refactoring. But a couple in there that I wanted to point out. So what do I have here? Allocate and render thick lines to texture for glow pass. So I think this was just what was this again? Oh, I think I just renamed some stuff. Move GL util. Oh yeah, I created a file called GL util, and I put a whole bunch of stuff. So I basically moved a lot of the code that I had been writing at the top of my GL render CPP, and I just moved them into a pair of files, glutil.h and CPP. What else? Move texture helpers there. Factored out some lambdas into functions and got rid of global reference captures. So again, more cleanup. Factor out shader pass lambdas into functions. So I had a bunch of lambdas in my main render function, and I promoted them into functions, which is something that, you know, if you've been watching my stream, you've probably noticed is something I do. I love to use lambda expressions as a way to kind of develop code within a function before I go, you know, the extra length of making it a proper function or a member function. Because one of the things that's really fun about lambdas is it's kind of like writing a member function that is only called from one function. If you want, that's one way to think about it. And because of capture, and because you can, you know, do like implicit capture or explicit there, but let's say implicit capture, and then pass parameters, you kind of don't need to worry too much about like what you have access to and all that. You sort of have a really easy way to develop and write your lambdas, and then eventually when it starts to settle and you're happy with the design, it's super easy to promote it. As opposed to say like, you know, the typical pre-C++11 way of doing it, which was like, you know, oh, I need to write a function to do this. So you just make a function, and then, you know, you're constantly changing the function because oh, I forgot a parameter, or I got to add another parameter, and then you keep touching the header file, which, you know, recompiles code, which I find really annoying, especially for functions that are just called from one other member function. So this is a strategy that I use a lot, and I find it really helpful because it keeps your code local, it keeps you touching one CPP, and you get to develop much more and iterate much more quickly that way. Create shader pass classes. Oh yeah, so this was more fun. Is I finally decided to create a shader pass base class and derive a whole bunch of shader passes from them. So I kind of moved my passes. Now this is not a polymorphic base class or anything. This is really just of a mix. Like the base is just a mix-in so that I can, you know, put some common code in there. In fact, I'll actually show you this code here, and I'll tell you why I did this. Okay, let's see here. So it starts over here. So I have this little simple shader pass class now. I've made a protected destructor so that actually I guess I should have made a protected constructor. Now I think about it. In any case, the point is you can't really create one of these. Yeah, why did I make it this way? I guess I should have done this. That would have been appropriate as well. Anyway, the point is you can't create a shader pass. This is just there, and all it does is it holds a protected variable called shader, because all of them will have one. And shader actually is a new class I also added while I was doing my refactoring. It's in my GL util here. And all it is a little wrapper around the shader resource. But it has like a nice little load shaders on it, which forwards to the actual utility. You can call bind to do the use program, and ID to grab back the ID. So that's shader. And then I have all my passes. And the reason why I decided to move my passes into a class is really for a very simple reason, is so that I can have this init and draw, where init will do like the shader loading, and the draw will actually do the, you know, setting up, the, like binding to the shader and setting the uniforms, and then calling the draw at the end. And all of this, I just kind of wanted to keep it in one place because I had them totally separated before, like loading shaders in one place and then using them later, and it was the separation made it difficult to understand. So now I can see my draw vector pass uses, you know, this vertex shader and this fragment shader, and then this is the code that goes with it, so it's easy to see. And like, for example, the darken texture pass similarly uses pass through and darken texture fragment shader, and here's the draw for it. The glow pass, same thing. And then, you know, because now it's a class, I can do things like make a little private function here. For the glow pass, I need to do two glows, one in horizontal direction, one in vertical. So I call a little private function to actually do each pass in here. So I guess glow pass is kind of a misnomer. It's more like glow passes, but anyway, it doesn't matter. And then here I have the game screen to CRT texture pass, which uses the draw texture, fragment shader, render to screen pass. You see it uses the draw screen one, and that's it, right? And I have my global instances here. And I tried to do some more cleanup in there so that the functions are nice and small and tight and easy to understand. So I kind of factored out a bunch of common code, and I think it's pretty easy now to understand. You got your shader bind. Usually it's bind a shader. Actually, usually it's always this part here, which is we need to set up like set the output texture on our frame buffer, followed by setting the viewport. Usually we clear, not always necessary, and then after that bind our shader, set the uniforms, and then draw. You know, and that's pretty much the pattern. So it's fairly easy not to understand what's going on. Here's another nice thing about the glow, having it in a class, is I can put stuff like the radius and the kernel values as members. In my draw here, I use the imGUI stuff to be able to slide them. But that's another nice thing, is if I wanted to, I could actually pass these as values. I could have setters. I could do all kinds of stuff with that. So yeah, it just kind of keeps them all together. So I had some refactoring, more shader pass cleanup, refactor frame buffer texture binding. Yeah, rename GL utils. Okay, I just didn't like the utils. I call it GL util. Create and use a texture wrapper class. Yeah, so this was actually a nice change. So I had some kind of confusing code with viewports. Sorry, I feel like I'm gonna sneeze. Okay, passed. Anyway, so yeah, I had some code here that that was rather confusing for me, and I'm sure for anybody reading it, where I was doing a whole bunch of stuff with sorry, is it this one here? Oh no, sorry, that's in the next one. Yeah, this one here was kind of a precursor. I decided to create a texture class, also in the GL util. So similar to the shader class, I have now a texture class over here, and all it does is the idea behind it is not only does it own a texture resource, but it also holds the metadata that goes along with it, which is the width and height. And I wanted that because I wanted to be able to query the width and height so that I can then set my viewport size to that of the target texture, which is what I do in practically all my shader passes, which is better than what I was doing formerly. So that's what this last change is get rid of this GCRT viewport and G overlay viewport and use texture dimensions to set viewport size and shader pass. So this was a change that makes me happy because it makes my own code less confusing to me. Why isn't this opening? Oh, it's opening on my other screen. There we go. so yeah, I added this, like, I had this set viewport where you pass a viewport in, which is fine. But then I put set viewport to texture dimensions, and you pass it a texture, which is that class, and then I do GL viewport 0, 0, texture width, texture height. So then I got rid of these extra viewports, overlay and CRT, which really were just a width and height anyway. I changed all my draws to accept directly a texture by reference. And then instead of doing set viewport to some global viewport value, I now just say, hey, let's set the viewport to match the texture dimensions of the output texture, which really makes a lot of sense since we are rendering to that when we want to render completely to that output texture. So that's what that's about. So yeah, that's pretty much the same change everywhere here. Here you see, like, I was using the CRT viewport width and height. Now I can just use the texture width and height for figuring out the resolution that we want to pass to the glow pass shader, to the glow shader. Same thing here. So yeah, just a bunch of nice little functions here. Oh yeah, this is kind of cute. This is like, I don't know how you guys would feel about this, but like basically I wanted to get rid of this overlay viewport, which was itself a viewport, and I was creating it based off the window viewport by saying 0, 0 for X and Y, and then just use the window viewports width and height. Similarly for the CRT, again, it's a viewport, so 0, 0 for X and Y, because I don't really care about it. And then I did a computation for width times the overlay viewport width times some scale, and the overlay viewport's height times some scale, right? So now I want to get rid of these guys, and I just needed to have the width and height. So rather than have 2 lines for each one and declaring them and all that stuff, I kind of made use of make tuple and structured bindings. So what this allows me to do is to say, the way I like to think about it is, like, make tuple is a way to create a struct with no named members. Hey Joshua Gallagher, I don't know if I said your name right there, but Joshua, welcome to the stream. So yeah, like the way I look at make tuple is it's a way of creating a struct with no, like, unnamed values, unnamed variables, I should say, right? So it's just basically a bunch of data members with no names. So that's what I'm doing. I'm saying, let's say, create a struct containing the width and height of this window viewport, and then do structured binding to decompose it into variables overlay width and overlay height. And we use type deduction. So whatever the types are of these, that's what the types will be over here. And I just thought that was kind of nice, you know, to be able to do this in one line, to destructure just random variables of some struct into local variables, and all do that in a single line. And actually, I looked at the disassembly of this kind of code using Compiler Explorer, and the optimizer just destroys everything, and you know, it's super optimal, and says, you know, in fact, in my tests, these just disappeared, and whatever values were here were being used directly where these guys were being used. So it's really amazing how the compilers handle this. Joshua says split keyboard. Yeah, this is it's my what's it called again? I forgot the name. The Matthias Ergonomic Pro. Yeah, that's it. The Matthias Ergonomic Pro. It's a mechanical keyboard, and yeah, because I have like RSI, so I do need a split keyboard. But I like that it's mechanical, so that the keys actually feel good and last a long time. So anyway, so I did that for the overlay width and height, and for the CRT width and height like this. You know, and what's cool is I could even slap a const on here, and they'll all be const. I guess I could have done that, but I don't really care too much. And then after that, I used them down here. So that's just a nice little C++ 17 thing that I enjoyed using. And yeah, the rest is pretty much all the same, just passing in textures instead of IDs. So that was that last change. And then just before starting the stream, I did a very small change, mainly for the stream, which is, oh, that's I just made now, but basically it's this here, adding a window height to my options file and just parsing that. And the reason why I did that is so that I can do for streaming. In fact, I think all of this is for streaming, really. So now when I run, it opens up like this, my emulators. So I don't have to keep resizing it and stuff like that. And I have my ImGUI controls on the side, and I have my main here, and I could just kind of start playing around with it. So I was getting tired of always maximizing and playing around and stuff. So Joshua says, I'm learning about machine learning. That's cool. I don't know much about machine learning. I know it's all the rage, and at some point I'll get into it. But yeah, I'm not really a pro or anything. But are you like following that very popular course there, the one from Stanford? It's like, it seems like everyone's doing that course. I think it's on, I forget, is it Udemy or something? Yeah, so this is basically where we are now, and where we left off last stream is we were about to write this one shader pass. So let's see, let's go here. I have this to do. So just like a quick recap, currently this is what we do when we render. So here's render scene. It actually now fits practically on one screen, except at this massive font size. If I go back to 100%, almost. Anyways, I'll make it larger for the stream. Joshua says, no, I'm just watching YouTube videos. Yeah, that's good enough. You can learn a lot from YouTube videos. So yeah, so basically what we're doing now, every frame is, so this is why the last stream is render normal lines and points, and we darken. So there we convert our lines into a line and point vertex arrays. Why did I do standard tie here? Oh yeah, that makes sense. Yeah, I have to use standard tie. And so here we have we call the draw vectors pass. So we do the draw, we darken. Then after that, we have this here, the render thicker lines for blurring, darken, and apply glow. So first we create a quad vertex array out of the lines. So if you recall, that converts all the lines into quads, you know, that go along the line correctly. So that makes like basically a whole bunch of triangles, which is why we then render with triangles here. As opposed to up here where we render lines and points, now we just render one big buffer of triangles. And then we do the darken on that as well, because we kind of have to maintain two separate versions of the same thing. We do the glow pass on it, which basically does the Gaussian blur in both directions. And then after that is the step I'm missing, which I'm going to write right now, which is we need to combine the result of this here and of this here. So like the thin normal lines, we want to render that on top of the thick lines into a texture, and then after that we can show that on the screen. And just to show you again, if we only were to render the output of like if we ignore this, right now we're doing this, but we're not actually seeing the output. We're only seeing the output from the normal lines, and you can see that over here because I'm using curve vectors texture 0 here. But if instead we were to use the final glow texture, you'll see instead like, you know, thick blurry lines. Like that. And you know, we can play with the glow radius here. Like if we put no glow, and then we can play with the line width and really make it thick. So this is basically what we're going to be playing with to try and get a blur effect. We'll see how it looks once we combine the two. I'm hoping it looks good. You know, it's gonna be like this, right? See how like really glowy that is? And I'm hoping that once I render the normal lines on top of this, it'll actually look good. So that's what we'll see today. Okay. So let's write this combine glow and normal lines pass. or maybe I could call it like I'll call it that. Combine glow and normal lines or something. Or combine glow and normal vectors. Something like that. Pass. Joshua says the glow looks awesome. Thanks, man. Appreciate it. So we're going to need, obviously, to load shaders. I'm going to have to write a fragment shader for this. It'll be like something like that, combine glow and normal vectors. And then our draw call is going to need to take in two textures, right? So let's say normal, all right, input, normal vectors, and const texture input glow, and I was right, vectors texture here, input glow. Now I'm just gonna write normal texture, and although I think the word normal here is probably not a good choice. Heavily overloaded word in the graphics world, right? Maybe I'll just, you know what I'll do? I'll say combine vectors, vectors and glow pass. Let's keep it simple. Because really it's a vector pass and a glow pass, right? So and then here I'll say input vector texture and input glow texture, or vectors texture, whatever. And then we need an output texture. Okay. So this is going to be basically mainly like the darken texture pass. In fact, it's going to probably be mostly like this one here. Where's the other one? Here. Here. It's like render to screen. So we do this. Texture dot set. Set. Actually, I'll do set viewport to texture dimensions. Yeah, I guess I don't really need to be doing these clears here. Doesn't matter. So we bind our shader, and we're gonna have two textures here. So we're gonna have the vectors texture and the glow texture. We don't have any alpha. And yeah, this is wrong. I gotta bind my output texture here. Okay, there we go. So that's basically the setup for the shaders. We're gonna have to go write this fragment shader now. But before I do that, I'm just gonna hook this up. We knit it, and now we can draw it here. We pass in, so what do we pass in here? We'll pass in this guy here, curve vectors texture 0. And we pass in glow texture 1. And for output, we'll use glow texture 0, which is a bit confusing, but it's because I know this one is used for, this is the temporary texture. And honestly, I should give it another name. Maybe I will there. This is basically a temporary texture and an output. So maybe this should be called like temporary, and this one should be called glow texture, and then this would be maybe make more sense. Anyway, for now it's okay. So I know that this gets used, let's say, for the horizontal, and then that gets used to make a vertical and a final pass into here, and then this one here is unused. So now I'm gonna combine these two back into the glow texture 0, and then I'm gonna have to copy it, I suppose. Oh no, then I'm just gonna draw this one to the CRT texture. Yeah, that's it. So this is gonna change like that. Perfect. Yeah, I totally need to rename stuff here. Because if this was called temp, this would be temp, 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 and it'll make more sense. So Joshua asks me, why does my set texture uniform take a parameter through a template? I'll show you why. So like here, for example, right? So the value you pass here is the texture slot. And that just allows me to not repeat myself twice in there, because I need to, where is it here? Yeah, it's this. So you know there's like the GL active texture, and you got to pass in GL texture 0 or 1 or 2 or 3. So basically to do that, I mean, although now that I think about it, couldn't I just do GL texture 0 plus the value you pass in? Probably could do that. Wasn't really thinking about, like, I don't know if I can rely on that. Like, if these enums were bound to, you know, whatever values, and I could not rely on the fact that I could add, let's say, an index, what this really ends up doing is it ends up calling this compile time function to convert the slot to a enum here, and then after that I can just bind to it. So that's really the idea behind it. I can probably rely on the fact that these are sequential, and you know, I can always add an index to the 0th one to get to the right texture. In that case, I could go back to not having, like, passing this in as a parameter. Anyway, it's not really a big deal, but that's the answer. I don't know if that makes sense to you there, if you see it. So, I mean, this is a compile time thing, right? I wanted to be able to, you know, let's assume that these enums here can have any value, and that we can't assume that GL texture 1 is actually GL texture 0 plus 1, right? So these are completely independent defines. They just define to some value. And so I need to do a GL active texture and pass it one of these. So 0 should be bound to GL texture 0 and 1 to GL texture 1. And I also need to use that slot for to set the uniform slot value here. You know how you have to get the uniform location for the texture slot, and you have to actually set the texture slot in there, the texture index. So since I can't, like, if I could make it a runtime variable, but then I'd have to do a runtime switch to get these values back. Like what I'm doing here, it would have to happen at runtime rather than right now, which is it basically is compile time. Like a set texture uniform gets generated for a 0 or 1 or 2, where it immediately binds to GL texture 0, GL texture 1, or GL texture 2. You know what I mean? So there's no runtime cost or lookup to figure out which one of these we want. The mapping is done at compile time. Does that make sense? Hey, what's up, Benjamin? So yeah, like I was saying though, I can probably rely on the fact that GL texture 0 plus an index will get me to the right value, and in that case this is not really useful. I don't know if I can rely on that. Is there like any I mean, probably in practice it's always like that, but I don't know. The Super Bible has something about it. Yeah, look, the Super Bible does it. Oh, well, there you go. For your convenience, the standard OpenGL header files define the tokens GL texture 1 through 3 to 31 as the values of 0 plus the values 1 through 31. So if this is correct, and it probably is, I don't really need to do it this way. So we could change that afterwards. It doesn't really bother me too much. Okay, so we did this here. And I'll just put a little to do here. All right. So combine vectors and glow frag. Let's go to my shaders. Yeah, it's probably the most like my draw screen fragment shader. All right, so let's rename our uniforms. We have vectors texture. We have glow texture. Don't have an alpha to worry about. Get the UV, and we have to output the color, yeah. So it's gonna be like this. RGB. Is there any alpha that I have to worry about here? I don't think so. Then basically what we do is we say if you know what? Maybe I'll do it this way. Okay, I'll say if the color that we sampled from the vectors texture is not equal to 0, 0, 0, then color will be the glow texture value. So basically what we do is, as long as we have a non-zero value in the vectors texture, we use it. Otherwise, we use the glow texture value. I think that's all we need to do. Oh, and I guess I shouldn't call this color. I'll go back with C here. Well, let's see what happens. Okay, it's compiled. Not quite what I thought it would do. All right, let me just think a little bit about this, unless I did something stupid. combine this and this into glow texture 0, and then put this here into the CRT texture, and then we draw that. Okay. Oh, sorry, it's the other way around. If what we sampled is 0, then we grab the other one. Totally the opposite. Ah, there we go. Wow, this looks pretty good. And we can totally play with the width and the glow radius. Just go back to my defaults just to see how that looks. Not that great actually. Lots of artifacting. Is this doing what I think? Maybe it's not really doing what I think. We're gonna have to go look at this in RenderDoc. Let's say, what was this again? I think I know what's happening. Let me just try something. Maybe 0, 0, 0 is too... Because I know that the darken pass brings it near 0, but doesn't actually snap it to 0 for a while. So let's put in some kind of tolerance in there. So like... because I don't have to write it 3 times, right? I can just write it once. So if it's less than... Let's say like 0.01. Oh yeah, okay. Oh, I can't do less than or equals. Const high p3 component vector vec3. So I can't compare less than or equal. It's not component-wise compare. Oh, less than. Perform a component-wise less than comparison of 2 vectors. Failed to compile with the following errors. Boolean expression expected. What did I do? Oh, it returns a bvec. Okay, compares each one. Oh, there's also less than equal. Any, all, or not. So if that is equal to, how does this work? I have no idea what I'm doing. Can't just use all. Benjamin says, can't just use all, right? I don't know, can I? All. Check whether all elements of a Boolean vector are true. Oh, okay, so wrap that in all. Oh, I see. Okay, so less than will return a vector of 3 bools. Okay, so that's what he meant when he said a lot, like also with all. Okay, so that worked. Thanks, man. Appreciate it. Okay, so does this look better? Okay, this does look better actually. Let's see how it looks in game. Still some artifacting, but definitely better, right? Yeah, better. Oh wow, you can totally see like the kind of the shadow of the ship in there. It's cool though. Wow, it's really cool. I mean, maybe it's a bit too pronounced right now, but it's quite cool. Let me see here. Just play a little bit around with this. Glow radius. Benjamin says, I think you might want to choose the brighter of the 2 colors. That's kind of smart actually. Yeah. It looks like you're getting black lines. No, you're totally right. Yeah, you're totally right. Why didn't I do that? And this is why we stream, right? Because we have awesome people giving us awesome ideas. By the way, the few of you watching there, you should totally check out Benjamin's stream. He's also an Emu dev who's streaming. So what did I say? We said we would do the max. Can I just do this? Not. Is it the max? Yeah, I guess. No, not the max. Whichever one is brighter. So yeah. How do I do that? So been slacking though. Been sick over the past 2 days. Nah, I totally understand. I'm also getting kind of sick. It's gotten really cold where I live. What if I did do the max? Right now, I guess it would be fine because all 3 values are pretty much at the same brightness. So I think this would totally work. Yo, that totally looks better, man. No black. It's cool, right? Like, if I go here, you know, like kind of like that glow effect. Although my lines are a little thin, and that's the thing, like I could make the base lines thicker. Nice, looks pretty good. Thanks, man. So that's another option, is I could like make the even the base lines themselves thick lines. I could try that. It should be easy to try and just see how that looks. How did I... I'm trying to understand why when I bring the glow radius to 0 now. Oh, okay, right. If I don't do any blurring, then we just see the line width without any blur, right? So that's just the thickness of the blur lines, and then that's with the glow. I feel like trying making even the baselines thicker, just see how that feels. The only thing is that when I did that, I had a bit of trouble with making sure I saw the little dots render. We put the overlay on this. You can change the point size too, that might help with the dots. What do you mean by the point size? Because if you mean like the OpenGL point size, is that what you mean? So I didn't check points, but I know like line width is not really supported by most shaders, so I don't know if point size is going to be supported. But what I meant is the point size can be configured in the shader. Like, do you mean like this function? Oh, this GL point size. Otherwise, the value written to the shading language built-in variable GL point size will be used. Could be kind of interesting to just see what that looks like. So like if I take draw vectors, I guess, You're saying if I set this in here, did not like that. Oh, in the vertex shader. That makes sense. Let me try in the vertex shader. Which in this case, I think I'm using, yeah, I have this one here. Okay, so that didn't complain. Okay, I probably have to do some enabling of stuff. The only thing that bothers me about this, of course, is that it won't really match the lines at all, right? Oh, it's working for sure, because I can see up here where there's some points in the corners, they're bigger. I mean, I don't know if I want this as my solution, because it does, like I said, it is like a mismatch between the way the lines are rendered and the points, and I kind of... Yeah, like you can see like the ship now. How do I... I think if I use my screen capture program, I can... Yeah, you know, you can see how like the points now, they don't match the size of the lines. So you get this kind of like weird effect. But you definitely do see the stars more. But like what I was saying is that, yeah, probably better to draw wide lines and points manually. Yes. So yeah, but I can, if I just go back here, so I'll remove this. So I mean, obviously I have a way to draw thick lines and all that, which is what I'm doing for the blur. So I could do it also for the base drawing itself, the normal, the thin lines over here. The only thing is I'd like to separate the width of the two, you know? But let's say as a simple test. Let's just try this. So now I'm going to draw the same thickness of lines for both the base and the blur. This is like thickness 1. Yeah, probably too thick. Or I need to really separate the two. No, we should play this game, Berserk, with the right overlay. Let me set that up. Let's go get Berserk. Did my overlay fail? Yeah. Oh no, it's not the art that I want. It's the PNG, right? Here you can see that my scaling isn't quite right yet. I don't know, look, the score is in the right place, so maybe it is okay. Yeah, I mean, obviously this is not a super good picture there, like there's probably all kinds of artifacts just from the picture itself, and it looks like the dudes are not drawn correctly on my in my emulator. They're like so tiny. Or is it just because it's not stretched properly? No. But yeah, it looks wrong. Okay, let's try adding a bit more control. Okay, so now I split the two and I have separate widths for both. It sucks that not everything gets rendered for some reason. Why isn't this rendering again? Yeah, it's because of this. When I pause my frame time, it goes to 0, so I don't do the buffer swap. And so the glow does that work? Line width for glow. No, I think it should have worked. Creates the thing. Draws to here. I darken it, whatever. And then I draw it. I know what I need. Instead of pausing, I need like a super slow timescale. That would just help to debug this. Like basically slow motion. This is a weird game, because you can just keep escaping. and the other image has a stronger bleed around all those lines. It's true. I mean, I could play with the kernel values for the actual blur itself as well. That definitely helps the bleeding effect, especially just the topmost, which puts a bunch of weight on the what is it again? It's the on like the immediate surrounding pixels, right? So the lines themselves get a bit stronger effect. This looks a bit more like it. But honestly, I don't know if I want to recreate what I see in this image, because it's a bit too strong, it's too pronounced. I don't know. This is a lot of the messing around kind of. Got you, humanoid. I don't know how to keep going. Oh, there we go. Well, I mean, I'd say this kind of looks like it, right? I love that death effect. These are pretty good values, actually. I don't know if you agree there, but let me write these down. That's one thing, I can't really save the values, you know? Let me just see if I was to use this on other games. So like line with normal would start off as a like 0.75 or something. Line with glow is 1.2. The glow radius is 0.75. So I think that's it. It kind of, kind of looks like one, right? This looks like I'd say it looks similar to the image. I mean, obviously this image is also brighter. Let me try going to I'm gonna use my joystick. I think what I'm probably going to do is have like, profiles for these settings. And you can choose between different profiles. Oh, it's not bad. Feels like nice and blurry, like the original. Everything's like super low res.
set my sail the wind it will take me back to my home, sweet home. Lie on my back, clouds are making way for me. I'm coming home, sweet home. I see.
Yeah, you're asking if that's the number of ships at the bottom. It is. And I know it looks kind of small on my screen, right? Like they look tiny here, whereas here they look big. So I mean, there's probably something about the timing. Maybe when you're at the edges of the screen or something. You're wondering if it's the same issue as Berserk? Yeah, I'm wondering the same thing. It's funny because like not everything seems to be affected in that way. You know, you would think like the ship and these mines or asteroids or whatever would have the same sizing issue. One thing I'm noticing is you see like the 7s here look kind of messed up. And I know part of that is this line width normal. If I make it, maybe not. I don't know. Let me try going back to having the normal lines again. Trying to get a 7. 4, 5, 6, 6, 7. Hi, I guess the 7 is a bit weird. Anyway, overall, I'm happy with the outcome. Obviously, there's lots of tweaking here, and I could spend like a long time trying to get it to look right there, and I won't do that on stream. And like I said, I'll probably provide some different profiles, you know. In fact, like doing the glow is actually fairly expensive. When I try this on my laptop, which is it doesn't have a GPU, like it has like an integrated GPU. So things like these kind of screen space effects for glow actually take quite a hit. I take quite a hit on my laptop, and so the emulator doesn't even run at 60 FPS. But when I disable all that code, it runs at 100 or something. And here on my more beefy machine, I'm at 100. Not that this machine is really beefy. It's like 4 years old or something. Like at work where I have a much better machine with a modern graphics card, it like runs at thousands of frames per second. So it's not really a problem on most machines, but it's just interesting. See this look right now, I don't mind this look, It's kind of like thin lines with a stylized glow effect. I think I almost prefer this look than to the one that looks a lot like, that looks more like the real thing, This just feels more, it just feels prettier to me. It's got those nice trails and Benjamin says, I know what you mean. I wanted to make my Game Boy emulator look real until I played on my real Game Boy again. Exactly, right? Like, why? Why make it look exactly the same when I can make it look nicer? Which is what I think most emulators try to do, right? They add all these like screen of, what do you call them? Like filters and stuff like that. Like the Super NES and NES emulators have these filters to make the pixels look less pixelated and look more sharp and interesting. Why do I have two darken speed scales again? Oh, because I'm doing darken pass twice, right? Alright, and each one has its own. I didn't even realize that I had that problem. But yeah, all of these really shouldn't be, directly embedded inside the functions that apply them. For now I did them that way, but these should all be extracted eventually. And then passed in as parameters. So this max here works, except that eventually I'm going to want to do color. So I don't know if that's going to be okay. Because here it maxes out it's component wise. What I really want to do is what you were saying, is whichever one is technically considered brighter. So maybe like, yeah, I won't know. But you know what though? No, I won't know. I guess it won't really work with color. But maybe maxing the components this way will kind of make sense. Thinking about like how the idea is that these three components make up the color, and whichever one has a stronger intensity is the one that kind of wins. It might work. Oh yeah, I never checked this in. I'm not going to check in my tweaked values. I'm going to just go back to the tweaked values I had before. And I'll spend some time doing my own tweaking. Actually, what I could do here, cool, check mark, checkbox. ImGUI is awesome. Let's see how this looks. I haven't really played with checkboxes yet, and a conditionally added slider. Oh, that's cool. And you see, some stars disappeared when I go to thick. If my base width is not thick enough, so I guess minimum is 0.5, which kind of makes sense. But see, 0.5 doesn't look the same. No, not even 0.5 is enough. See, some stars disappeared. And I don't really understand it, because I mean, in the end, these are Maybe it's because they're not actually quads. They're kind of diamonds. That's what I'm doing for the points. I should try to make quads. See what that looks like. It doesn't make sense to make diamonds. What is it again? It's up here? Create quad, yeah. Okay, that makes more sense. Let me just bring down. Turn off the glow. I just want to see here. Yeah, so at least at 0.5, we are sure to see everything, including the point. That makes sense. See, and then that's the difference, right? Like, when I don't use thick base lines, I'm drawing GL lines and GL points, and you can see they look thin and all that. If I turn on the thick base lines, even though I set the width to be 0.5, which is, it's actually, I say line width, and it actually is a line width. I divide it by 2. So actually, 0.5 is really 0.25 on each end, right? Making a width of 0.5. That's still thicker than when I just do a regular GL lines. Like this is a width of 1. Definitely thicker. It's interesting. Where's my magnifier? If I can show this without. Can you like set a magnified region with the magnifier and then move your mouse around? Anyway. Yeah, I'm not convinced that having the baselines be thick adds much actually. Improve quad. Oh yeah, I wanted to do this. You know, I'll do that as a second. Implement, combine, vectors and glow, shader, pass. Whoops, that's not good. Hold on. Okay, so I think it now makes more sense. When we do the glow pass, we have a temporary texture that's used for the intermediate pass, and then we get a glow texture as outputs. We combine the vectors in the glow texture back into this temporary texture, and it's the temporary texture that we scale to the CRT texture, which is then drawn with the overlay texture to the screen. I think it might be interesting to just see what RenderDoc does with this. Make sure it's doing what I think. It looks like it is. It would be cool to be able to name. I'm sure there must be a way, right, to name the draws you make. So this is the draw of the current screen of vectors into a buffer that has previous screens that have been darkened. I don't know why I have two. Oh, this is the thick version. That doesn't really show, eh? Oh no, that's the thick version. So I don't know what this second draw call is. Looks exactly the same. So this is where we darken it. This is where we draw the thicker version. That's where we darken it. This is the horizontal blur being applied to the thick version, and then the vertical blur. And then here, this is where we take the glow texture and the vectors texture here, and we combine them to produce this one here. So there's the blurry one, there's a not blurry, this is the combined. It's cool. Then that gets resized based on the scaling factors into this larger texture that matches the window size. And then that finally gets, yeah, then there's some stuff here that comes from hello? From ImGUI, if it'll actually show. Oh, crap. Is the camera all messed up? Wow, RenderDoc like messed everything up. How do I bring this back? Is it all messed up now? Thank you, RenderDoc, for... Let's see if I can fix this without actually shutting the stream. I don't know. I know what's going on here. Okay, well, let me just, I'll stop and I'll come back, I suppose.